Good afternoon. My name is Greg Freeman. I'm a residential home inspector, and I also work with Champions Go Real Estate. Part of the inspection business is changing. New home inspections are becoming an increasing part of the inspector's repertoire of jobs that they're asked to work on. Now, doing a good job for your client isn't hard to do in new home construction if you just know what to look for. The first thing you need to do is prepare a proper worksheet of things that you're going to inspect. This prevents you missing things that are important on the site. I have a matrix for new home construction just like I have a matrix for resale homes. Now, new home construction is basically two different inspections. We want to inspect today what we call a slab foundation before the concrete is poured. The next phase, which we'll do tomorrow, will be a house being framed. It's important to get into a frame house before the insulation's installed and certainly before the sheetrock goes up. So here today, we're here to look at a home being prepared. We're going to look at the slab just before the concrete is poured. One of the first things I look for when approaching a new home construction site is, do they have a relief trench? A relief trench is just like it sounds, is for excess water to drain away. Particularly it's important late spring, early summer. We get brief thunderstorms. If it gets too much water here, it doesn't drain out properly, it's going to make a difference when they pour the slab. A more serious problem could be if they don't have a relief trench, the sod and dirt can collapse. And this is sometimes a problem, particularly if they try to pour concrete over here if part of that dirt has eroded away. One of the initial things we look for in a construction site is a copy of the plans. These plans are essential. And unfortunately, only about 1 of 10 new home sites that I check have a copy of the plans on site. What as an inspector you want to do is get those plans out and read how many tenants you're going to have, the depth, and other specifics. This is where the engineer and architect put in how this place is to be designed. And part of our job is to enforce the engineer and architect's desires to how this house should be built. These plans tell me how many tendons or cables, if you want to call them, are required to properly construct this place. It tells me how many upper tendons we have, how many lower tendons, the spacing aside. It tells me how deep the trench should be. It tells me an indication of how much exposed soil or undisturbed soil I've got to find around here, etc. So this is your blueprint, so to speak, that we're going to follow to make sure it's been done correctly. Take a moment to look at the beams. Of course, the beams are what we call the void space between the squares. Those squares should be sectioned off, as I said, into squares. If the sections are rounded, that shows an inexperienced crew, and the rounding results in the soil around the beam caving in. As you can see on this site, this is a pretty good experienced crew. They're fairly square. I don't have much caving in, which gives that rounded look, and that's certainly a good sign so far. Now, the next thing I want to do is count the number of tendons or cables. What you should always do first is count the number of top tendons, and we go, basically, you go front to rear. I'll count to make sure the same number of tendons here are the same numbers required for in the plans. When we start to count our tendons or cables, we always start with the top tendons first. We go front to back. For example, 1, 2, 3, 4, 5, etc. And I'm going to compare the number I counted here in the field with the number that required for in the plans that I looked at earlier. My next step is to count the top tendons from side to side. Using the same procedure, I'll start at this side, go 1, 2, 3, 4, 5, 6, etc. Once my count is finished, my field count, I will then compare the number of tendons I counted to, once again, what was called for in the plans. If there's any discrepancy in the number I count in the field versus the plans, I've got a problem. The tendons requires a discussion of the chairs. The chairs, the plastic sort of lifts that hold the tendons off of the vapor barrier. Anytime tendons intersect, they have to be in chairs and what we call wire tied. Wire tie is basically the piece of metal that's wrapped around the tendon and the chair to secure it in place. These are the wire ties right here that I referred to a minute ago. Once again, anytime our tendons intersect, they need to be in a chair and have these wire ties wrapped around to hold them securely in place. Once we've counted and verified the top tendons and made sure they're correctly tied, we need to zoom in on the bottom tendons. The same procedure as with the top. We count first from front to back, counting 1, 2, 3, 4. The tendons are at the bottom of our trenches. And then we're going to verify our field count of tendons with the tendon count required in the plans that are here on the site. Now, we now have to look at the bottom tendons from side to side. Same procedure with the bottom tendons from side to side. 1, 2, 3, 4. I'm counting the number in the field, bottom tendons side to side that I have in place. Then once again, I've got to compare that to the number required in the plans. As with the top tendons, if they're not correct, we need to notify our clients so they can get a hold of the supervisor and say this is not following the the architect or engineer's specifications for the site. Residential and commercial slab and grade construction requires plastic chairs at the intersections of the tendons. These chairs support the tendons so that they are surrounded by concrete. The cable will still compress the concrete without concrete around it. However, unchaired tendons are exposed to moisture, and that can cause premature oxidation. Besides, the architect wants to make sure they have adequate support, and our job is to help our clients enforce the architect's design. Those are called anchors. They're pieces of manufactured metal that hold two 20-pound nails. They're to hold the anchors, the tendons, very securely in place against the form board. It's very important to make sure that each of those anchors has 2 nails in it. I've often found builders only put 1 nail in it. When they pour the concrete, it's too heavy and it'll come off of the form board. So it's a part of our job is to check each anchor around the slab and make sure there's 2 nails in each of them. Something else that's happened here is the local community building codes require in this section that the ends or exposed ends of the rebar or tendons be wrapped in duct tape to prevent oxidation before the slab is poured. And that's what's done here at the end of these tendons that you see. The naked ends are wrapped in basically duct tape, prevent moisture getting through and rushing it before the pour is made. Another part of the anchors we have to inspect is to make sure these anchors are at least 3, hopefully 4 more inches from the corners, and obviously they've done that there. If you have them less than 3 inches from the corner, you run the risk of what's called a blowout. When they go to put pressure on these steel tendons, they're going to put about 38,000 psi. 38,000 psi is a lot of pressure. If you don't have sufficient concrete in the place, you could have a blowout when these cables comes up through the concrete. And once again, the anchors have to be at least 3 inches from each corner to make sure there's sufficient concrete to prevent a blowout or pop-out. After our pour, it's very important, if we're still engaged for another phase of inspection, to make sure all of these tendons are stretched. Unstretched tendons are a serious problem. Now, basically, if the cable's not stressed, that part of the slab will be unreinforced. All tendons here should be tensioned within 6 to 10 days after the concrete is placed. So now, the elongation measurement is confirmed by inspection. The cables can be cut and capped. The elongation measurement usually requires about 38,000 psi. And if any of these cables are not sufficiently stretched, then the load will not bear on that area where that cable is in the concrete. One problem we want to prevent with this tie again is that our top cables, so they aren't flopping into the beam area, they have to have a wire here as well to hold this top cable once it comes out the anchor at the top. See where this wire is wrapped around here, prevent what I call flopping in the breeze into the beam. It must be secured as soon as it comes out the ankle where it attaches onto the tendon. Another part of our inspection is to see how many inches down the site is excavated below the form boards. Depending on the characteristics of the soil and the weight of the load, the engineer will dictate in the plans how far down below the form boards the soil must be excavated to what's called undisturbed soil. This is usually at a minimum 6 inches, somewhere usually 6 to 9. And let's look here, looks like we've got over 8 inches of undisturbed soil, so this slab is in good shape. Those pieces of steel there are called in the industry crank bars, and they're number 5 steel. They're placed in the corners for extra strength. Now, the steel is ribbed. Some people believe that's so it can be gripped easier. Well, that's probably true, but the real reason is it makes it easier to tie another steel bar onto it with a tie. As you notice there, where it's been going out of the slab, they have ties again. They're onto those crank bars. Once again, the architect or engineers required additional strength at the corner. We call this piece of rebar, or called in the industry crank bar. While we're up here on top of the hill of fill dirt, let's examine the vapor barrier. The vapor barrier is required to be at least 6 mils thick. The average trash sack is about 1.5 mils. The container they roll the vapor area out of has 6 mils stamped on it if you happen to be there when it's being rolled out. Otherwise, you can tell the thickness by actually feeling it. It's much thicker than typical garbage sack. Now, it's very important where these vapor barriers come together in sections, they must overlap anywhere from 6 to 12 inches. Where the overlaps are, you have to put duct tape across to hold them in place. An extra bit of security, as the builder's done here, is to sometimes put a big nail in there into the duct tape to hold it, just like you're sewing material. The nail is doing the same purpose, holding that duct tape in place so it doesn't move. And of course, by doing that, it holds the vapor barrier. The vapor barrier prevents moisture from coming up through the slab. There's no concrete is porous and getting into our house. It's very important to be intact, securely tied down, and we have that 6 to 10 inches of overlap in that vapor barrier. These are called form strings, and these should form an X pattern across the top of the vapor barriers. The idea here is to make sure we know that we have at least 3.5 inches of coverage over these top tendons. As you can see here, we have the 3.5 inches. Once again, it should form an X over the top of our vapor barrier, and that's how it's basically these strings go off the top of the form boards, so we can measure and make sure all across here there's at least 3.5 inches of concrete over the top of these tendons. The plumbing pipes, of course, are put in before the foundation is poured. The plumbing pipes have to be covered with a mastic, which is a tar-like substance, to a depth at least 3 inches above where the concrete will be. The mastic is there to prevent water penetration, also moisture, and also keep insects such as termites from coming up through protrusions through the slab. Obviously, this needs to be checked to make sure it's masked before the concrete is poured. Another factor is at least one of these plumbing protrusions, the caps are not glued down. Now, I've removed the cap that was not glued down on the plumb protrusion right here. We're going to make sure there's water inside there. You may not be aware of these, but all these plumb protrusions are filled with water before the slab is poured. We're going to check the water level, or the builder should check the water level, come back some hours later and make sure that water level has not gone down. If it's gone down, that means you have a leak in your plumbing lines. If you pour foundation when you already have a leak in the plumbing lines, you're talking about big trouble. As you can see, there's water inside this pipe. It goes all the way down here. And once again, the builder has to ensure there's a constant level here. Now, something else that's sometimes done is what we call burping the line, where we'll go to another plumbing protrusion that has not been, where the cap has not been glued on. You pull it off, and it's what we call burp, lets air out, and this should go down a little bit and just shows it's a closed system. You may find of interest these pieces of lumber that are sloped here where there's going to be a porch or patio area. I'm willing to bet this is going to be basically act like a wheelchair ramp with those slanted boards. That way this community, I believe, is going to be for active seniors 55 and over, so if they get aged and need a bit of wheelchair, it's already got the ramp installed. So those kind of boards, you can see where it's going down is going to be a slope, a gentle slope for wheelchair ramp if someone needed that down the road. Obviously, your tendons have not been stretched here. Once again, that'll be done within 6 to 10 days of pouring the slab. But what I want to point out here is it's important to make sure that none of these are unstretched or untensioned. What will happen, the inspector will come by after about 6-7 days to put white paint on the end of the rods. That means it's okay. They've done a preliminary test, okay to stretch. You'll see some white paint at the end. That means they're going to come by within a day or two with a hydraulic jack and put that 38,000 psi on those tendons. Those boards that you see outside of the form boards are called batter boards. Any of those nails sticking up, strings will run off those. And very important to make sure those align correctly, because based upon the strings run off those batter boards, they're going to set the form boards. Now, if they get off a couple inches, you get in a situation where when they set up the forms and then go with the slab, your plumbing protrusions stick out in what's called a brick ledge here. If they get in the brick ledge area, the effect of that is the guy putting up the bricks is going to kind of have to weave his way around those. And people blame the brick guy. It's not his fault. What happened is they got the batter board stringed off a couple inches. The plumbing protrusions get down to where the bricks are going to go, and the brick guy had to kind of walk it an inch or two around that ledge. At various places around the slab, I want to see what the total depth is, and this is a little bit over 25 inches. Once again, the depth is going to depend on how much excavating that the engineer wants done at the site. Construction site, this is the very first stage of preparing the site, or a slab, I should say. You notice the batter boards are here, the strings are there, and you see where the form boards goes up to the top of the string. And once again, it's very important to make sure that's exactly straight or you get problems down the road. Now, as you can see, there are batter boards at each corner of the site, and those strings have got to be exact or we're going to have a problem. The strings, once again, the top of the string is as high as the form boards will go, and they run strings in each side. If you can look the other side across there, you'll see strings going that way as well. This is your sewer cleanout cap here. It's got to be capped always from top, prevent people from pop bottles, debris, whatever down here. Now, this will be the last thing that's done in the building. Once it's been framed, insulated, etc., they'll cut this down to ground level. They keep it high, just prevent a backhoe or other construction equipment from running over this thing and knocking the cap off. Your job as inspector is to make sure it's capped at all times when you're inspecting it. If it's not capped, you need to holler. Once again, as I said in the opening comments, the clipboard keeps you on target to things to make sure you've inspected it. One of the other comments I always put in my reports was a supervisor or building superintendent on the job during the time of my inspection. If it is, just want to make a note to that effect. I also want to point out there are certain times you need to red flag a site and let your client know. Think conditions such as they have totally disregarded the architect's or builder's, or the engineer's instructions via the plans versus what you found on site. Another time you want to basically raise a red flag is if the tendons are not supported. I have seen sites with missing chairs all the way across. And seriously damaged vapor barrier. These things deserve a red flag. It needs to be reported to your client, to get with the builder and get this cleaned up, get on the subcontractors and fix it before the slab is poured. Once again, once the slab is poured, it's extremely expensive and very reluctant for a builder to go back and make the changes. Next, we're going to be looking at homes that are farther along the construction process, the framing stage. Ideally, you'll be called in to inspect the house before the insulation goes in and hopefully, certainly before the sheetrock or drywall goes in. That can hide a lot of sins. Construction at the next phase, and one of the things you're going to be required to have is a hard hat. If you don't have one, you need to get one because most builders are required to have a hard hat to enter the area while it's under construction. Now, when you first approach a construction site, I like to see what I call a managed defect. A good builder does that. What do we mean by managed defect is all the bricks on one side of the driveway, maybe a can for trash the other side. They'll keep one side clean there where people can get to the site, whether it's trucks or workers or whatever. And also they'll require that people park on one side of the street and so it's not blocked off so people can get to it. And this site looks to be pretty good, what I call managed defect. You can see that the bricks are on one side of the drive, they have a trash can at the other, allows entry for people to come up to the site. That's a good managed defect. Sometimes you're called out to do a first phase inspection. The slab has already been poured. That limits what's available for you to check. Now, we're going to go up on top of a slab that's right here that's already been poured, but before we do that, we want to look at where they're going to put the driveway. As you're going to see in a moment, the first section, 8 to 10 feet, is required by the county that ties into a public road to have steel rebar. As you can see, the first section here has steel. That'll be raised up before they pour with chairs to keep it in the middle of the slab. The sections beyond that, you can see where it's cornered off. It will not have any steel unless you pay for it. If you don't put steel in, after a few years, it'll look like a mosaic tile. Always tell people if you're going to be there for the long pull, or tell your clients you want to pay to have steel rebar go all the way up the driveway. At this stage, they're just in the process of taking the form boards off the slab. Now, as we mentioned earlier, the form board should be removed in the first 3 days. Sometimes this summer you get a lot of heat. You could pour in the morning and actually basically pull the form boards off by that evening if it's a lot of heat in, let's say, the end of July, 1st of August. Now, I've had a little rain. This is about the 3rd day, and they're just starting to pull these form boards off. You've got to be careful when these are pulled off that you don't damage the concrete. As you can see here in that little corner there, there's some damage. If there's any damage, that's have to be scabbed over. If there's any honeycombing where they haven't vibrated the slab properly, that'll have to be scabbed over as well. After the form board's removed, all the nails have to be cut off. And they've just started the process here, but if we're back here a day or two later, we'll make sure all those nails have been removed. Can't tell you how many sites I go to, you have a couple of nails sticking out years after the form boards have been removed. These are called anchor bolts or J-bolts. This is what secures your superstructure to your foundation. Now we've got to check the spacing. Once again, it cannot be more than 6 feet apart. Got to make sure there's enough sticking out where the board will go over it. These come in either 8 or 9 inch lengths. The requirement is under our code that at least 7 inches must be embedded. That means concrete plus the board that fits over the top. So I'm going to go around, make sure we have proper spacing on the J-bolts or anchor bolts. I'm also going to look here at the back to make sure all my plumbing protrusions are tarred and see if they've removed enough of the form boards away so I can see if there's any damage. As you can see, we're checking the depth here, as most of these are around 8 or 9 inches. This one's he's using around 9-inch anchor bolts or J-bolts. I've got basically right now in a 9-inch, I've got 3 inches sticking out, which is fine. The board will take another inch, and that'll leave us over the 7 inches that we have to have minimum embedment. That'll leave me room for my washer and nut at the top to secure it to the sole plate or base plate. So I'm going to go all the way around, checking to make sure I have enough height. I'm going to repeat this all the way around the sides. This one's fine, but I look like I got a problem here. Now, this one here is not sticking up far enough. Now, when we put a board over here another inch, you're going to barely have enough room to grab with a washer and with a nut. Now, I'm not that concerned because he's got enough close spacing to more than compensate for it. If he had these in 4 6-inch or 6-foot spacing, I'd have a problem. Because he has other anchor bolts that are all right, they're close enough, I'm going to let this one pass. You can see the tendons coming out here. These obviously have not been stretched. This slab's only about 3 days old, and as I told you before, they're going to wait somewhere between 6 to 10 days where they're going to stress or stretch these tendons. Once again, the company that's in charge of that will come out, they'll put some testing, then they'll put white paint on, means it's okay to pull. They'll then get the hydraulic jack and stress them, then clip them. Once again, you have to make sure after that's done that the nails are removed. Remember, once these tendons are pulled, they have to be grouted or capped with a non-shrink grout, and make sure again the nails are out. If the grout comes loose, air will get the tendons and oxidation will result in rust and the loss of tensile strength. The grout is often knocked off also by homeowners carelessly using yard equipment such as weed eaters. I'm often asked why slab construction is not used up north. It's basically simple. Why don't they build with walls and piers? Why don't they use slabs up north? Well, the reason is the ground freezes in the winter, and this freezing can shift the slab at worst and at least lead to cold floors in the winter. It's also a reason why most homes up north have asphalt rather than concrete driveway. You get that frost heave, you're going to have a lot of cracks in the driveway as well as your slab. Once again, the slab and grade like we have here is traditionally used in the south. It would not work up north. In the background there, some workers are currently pulling the form boards off that slab. It's a long device such as a crowbar they have to pull it off. It's been a little over 3 days now. It's getting hard to pull off. And the sooner you can pull them off, the less resistance you have, the less possibility of damage. Of course, they had some rain yesterday, so you had no choice but to wait another day, but it does make it harder on the crew to pull the form boards off. And we've got to make sure that all of our plumbing protrusions are capped. And you can see at the bottom where they have the masking or the tar-like substance that's 3 to 4 inches above the slab. Once again, these have to be secured. These caps prevent foreign objects from getting in there. So if a frame is strong, it provides the necessary support for everything that follows. But if the frame is weak, no amount of expensive finishes will hide the flaws. Perfectly plastered walls begin to crack. Every time a door slams, those beautiful granite or Corian countertops will slowly fall out of level, and expensive wooden floors will bounce and spring. Shortcuts taken in framing a house parallels a bad foundation as a disaster for the homeowner. This is compounded by the fact that it may take 4 or 5 years before these defects show up. And as most builders only give a warranty of 1 year, basically the homeowner has a serious problem in his hands. Now, the house behind us is in the framing stage. We're going to spend today looking at framing. Now, let's begin in framing. They should always use the right nails. The IRC code, International Residential Code, which builders are required to follow, specifies the length, girth, and number of nails in critical locations. Inexperienced crews often overdrive nails. A nail that is driven too deep below the surface of the wood will not pull its full weight. Joists, studs, and rafters should be exactly 16 inches on square, on center, or unless the plans specify otherwise. This house today, we're looking inside, do a framing inspection, as well as some other items. As we first approach the house, you want to walk around and look at the drainage. Now, the code requires a positive slope away from the house, what's called 6 and 10 feet, which means the first 10 feet away from the house, the elevation must drop 6 inches to allow for proper draining. This prevents water ponding, which of course can lead to foundation problems. The issue usually is in the front yard. As you can see here, there's a good slope, certainly more than 6 inches in the first 10 feet, so water will definitely drain away in the front. However, we've got to walk the sides as well, make sure there's a swale there, or will be if there's a house next to us. And also what we've got to do is make sure that there's proper drainage in the backyard. Usually the issue comes up in the backyards. Now, as the first thing I look at, I can see a nail still left on there. That's got to be taken off. You can see in the corner there's some scabbing and honeycombing on the very corner of the slab. Once again, you can see this the corner here of that slab. We've got a bad corner. They're going to have to scab some concrete on. Also, it's a good idea to walk over and pull up the vapor barrier or poly there just to make sure we've got a good slab. I always like to walk over, grab the side of it, and just look at it as it go down. Generally, it's got a pretty good pour here, but we want to go along checking the whole issue out and make sure we don't have any bad spots coming down. There's some minor ones here, some little rough edges here. You can see here in this corner we've got a problem. They've left one of the nails there, and that's obviously going to have to be taken care of. Should be cut off. Let's look here also. You can see where the tendons coming through here have been capped off. And that's very important for the homeowners to make sure they keep that cap on there. Oftentimes over the years, weed eaters and other garden tools cause a problem by knocking that cap off, which could lead to oxidation. Look at our backyard. The drainage isn't that good. Let's give the builder an opportunity to go through and correct the drainage, but we want to make a note to our client, make sure that this gets better grading before they moved in. It's too flat. You're not going to, in this present mode, it's not going to be proper drainage. It's something that needs to be corrected, certainly before any landscaping is done. Now, one of the things that we want to focus on first is what's technically called styrofoam put out by Dow, but most people in the trades call it a blue board. It's very important those blue boards be free of dirt, because those blue boards come together, they have to be taped for insulative reasons. They want the Energy Star seal out there. The Energy Star inspectors make sure every time the blue boards come together, the styrofoam, that there's tape there. Now, some builders use a good metal tape. This builder tends to use the plastic, almost like a cellophane tape. That's fine, they'll both work, but if it's not taped, every one of those, they will not get their energy efficiency, because you leave allowance for wind to get into the house and lose heat in the winter and have heat enter in the summer. Don't ever put duct tape on that. Any wetness gets to duct tape, it'll come right off. Now, next to the blue board, we have what's called Thermoply. Now, it's very important to make sure, believe it or not, the Thermoply can be used around your doors and windows. It may be hard to understand this, but this stuff actually has some structural integrity to it. It gives a little extra added strength. Now, in my perfect house, I would have OSB board or plywood used here, but they've used this Thermoply, which it's adequate, I guess I would point out. It's very important to make sure they have the red writing on this Thermoply. They make a green one, which is for inside only, not to be used outside. There's several times I've caught and used the green lettered Thermoply rather than the red. Now, something I want to call your attention to on the Thermoply is these hash marks. These hash marks are spaced 3 inches apart. As you can see here, every 3 inches you have these red marks. Now, you should not go more than 3 red marks without a nail. If you don't have a nail within 3 red marks, it needs to be pointed out. And he's pretty close here. As you can see, 3 is a little bit here, 3, 6, 9 is a little bit long here. Got one at the bottom, he's a little bit of a gap. I'd have had more nails put in there. In fact, I'm going to write that up. It should not be more than 3 red lines without a nail. That gives, if you're going to put it on here, if you don't have enough nails, the wind can tear it. Once again, these are every 3 inches. I don't like to see more than 3 red lines without a nail in there. Now, this is just a minor hole here, probably caused by someone getting a little too carried away with a hammer, but whether it's minor or large, all penetrations through the blue board have to be sealed. Another thing you have to inspect around the house is this Thermoply must be at a minimum 1.5 inches above the concrete. The issue you run into, if it's less than 1.5 inches, it'll wick water up from the concrete. And so even though you've got a vapor barrier here, once again, it must be at least 1.5 inches off of the concrete. Here it's closing in a little, almost 3 inches. That's fine. We have to check all the way around the house to make sure where we've used that. Here's a little closer. Here you've just got a little over 2 inches, but once again, it has to always be at minimum 1.5 inches off the concrete anytime you're using the Thermoply. As you can see, he's already started plugging some holes with that foam. Also, to your right there, you can see where he's used the, what I call plastic tape, where the blue rock's coming together. If you look where those two come together, just to the right of the hose bib, rather than the silver tape, he's using this cellophane tape right here to hold those two sheets together. I prefer the metal, what they call basically airplane tape. It's a metal shining portion. It's a little cheap for the cellophane, but it will hold. And once again, you